Hello, hi. In this episode, we are going to learn the formula for first order differential equation, first order linear differential equation. So I will request if you can view my previous video where we discuss linear and nonlinear in general, right? So let's remind us quickly. A first order differential equation is linear if it can be written in the following form. A function of x, a of x times y prime plus some function of x, let's say b of x times y equal to some function of x. So the linear means we have a separate term for y prime and we have a separate term from y, and there is no mixing of y and y prime. In other words, there is no y square, or there is no y times y prime, there is no y prime square or y prime cube or y cube, anything like that. And also y and y prime cannot be a argument of another function. So for example, we should not have sine of y or ln of y prime, something like that. Okay. So in other words, we can rewrite our differential equation in this following form, right? Okay. So any differential equation can be written this way is linear, first order linear. And first order means we only have y and y prime, no y double prime, etc. So at this point, we can assume that my function a of x is not the zero function. It's not identically zero function. Okay. A very quick explanation. I mean, the difference between if I write a of x equal to 0 and a of x, this three line equal to 0, there is actually a difference. So this means that you're basically solving for x. So for example, so for example, there may be some particular value of x where my a of x could be 0. So this means that there may be some x equal to 1 or x equal to 2, there may be some particular value of x when ax can be 0, and this means identically equal to 0. That means that a of x is equal to the 0 function. As an example, let's say my a of x is x squared minus 1, right? So if I write my x squared minus 1 equal to 0, there are some particular value, x equal to 1 and x equal to negative 1. Those are the two value where this is 0, right? So that means it is possible that my a of x is 0 for some particular value of x, so no problem. But this is not equal to, so this function x squared minus 1 is not identically equal to 0. No, I mean, this is x squared minus 1. It's not the 0 function, right? It's not always 0. So this means it's always 0 in some particular interval. The x is always equal to 0. Okay, anyway. So because my a of x is not identically equal to 0, I can divide both sides by ax as long as x is not that particular, x, as long as we avoid those value of x where a of x is 0. Okay, so let's do that. So let's divide both sides. So here, let's divide both sides by a of x. And if I do that, let's actually do that. So if I do that, I'm going to have y prime, because a of x will cancel out. B of x divided by a of x, y, equal to c of x divided by a of x. Right? See, I divide both sides by a of x. Now, b of x divided by a of x is some function of x. So let's just call it p of x, just by one letter name. Why calling b over a? Some function of x, just call it p of x, same idea. c of x divided by a of x is some function of x, right? Just call it q of x. Why call it c of x over a of x? At the end of the day, it is some function of x. So just call it q of x, right? Okay, very good. So at the end of the day, all I have is y prime plus p of x y equal to some function of q of x. So this is the standard form of the first order linear. So this is the standard form. So when you solve for linear first order, almost always you have to express this in the standard form. In other words, just make the coefficient of y prime 0. If you have any function as a coefficient of y prime, for example, x squared or sine x, divide both sides by that function to make it a standard form. Now here, in a shortcut, we're simply going to write y prime plus p of y equal to q. Well, it is understood that the all of this letter p is a function of x, q is a function of x, and so on. Even we know that the y is some unknown function, but it's a function of x. Again, I'm using x. In some instances, it might be t. All the functions are functions of t, so that's okay, no problem. How you solve a linear first order differential equation? So in a very few times, you actually have an explicit formula to solve a differential equation. This is one of the exception where you can actually write down a formula of solving first order differential equation, and it will actually give you an explicit solution, not implicit, explicit solution. So instead of giving you the formula, let us derive this formula. So we start with this equation. Now, whenever you have an equation, you can add something to both sides, you can subtract something from both sides, you can multiply something to both sides, right? You can divide both sides by something. So you're allowed to do that as long as it is the same function. So here, let's actually make it more complicated, and this will help us. Let's actually multiply both sides, and this is you're going to see why I'm doing it. So let's multiply both sides by some function which we do not know at this point. By some function which we do not know at this point, let's just call it u of x. And this u of x has a special name. Actually, I'm going to say it later, so forget about that. So some unknown function u of x. I mean, you can choose your u of x anything you want, right? So I can multiply both sides by x squared. I can multiply both sides by sine x. I can multiply both sides by ln of x, anything I want. But if you multiply both sides by anything you want, of course, you're going to make things even more complicated. So we have to choose this function very carefully. So we need to choose a very specific u of x, which will do a very particular job. And I'll explain what is that job is. So I want to figure out a very specific, a very special u of x, which will make our life even easier. Okay, first actually multiply both sides by u of x. Again, I'm just going to call it u, but in your mind, it's just everything is a function of x here. So let's multiply both sides by my unknown function u. We don't know what is that function u we want at this point. So I'm multiplying both sides by that function u. So what is this u should be so that this actually help us? So what we actually want, we want such a u so that the left hand side, this left hand side will be equal to uy the whole thing prime. So that is what we want. I mean, it's not going to be true for any u. There may be a very special u where this will happen. So the question is, what my u should be so that this equality is true? Can we find such a u? Let's try that. And then we'll come back to this equation. So we're going to concentrate on this part here. So that we're going to concentrate. So what we want such a u. So we want such a u so that this left hand side, here, let me copy that, is equal to this u y the whole thing derivative. Can we find such a u? So let's do that. So this one I can use the product rule. So that's just u prime y plus u y prime, simply using the product rule. Of course, here the derivative is always with respect to x. So that's the product rule here. I can cancel both side u y prime, right? I can subtract both side u y prime. I have the same thing. So I can cancel that out like that. Okay. And then let's write it down what I have. When I cancel, it becomes much more simpler. I have this upy on the left and u prime y on the right. Let's divide both sides by y. And again, whenever you have to understand that whenever we divide by some function, for example, y or u, we always understand that we're avoiding those x or those value of x where the function becomes zero, right? Okay, so let's do that. So what okay, we have up equal to u prime. I want to know what is u. Remember, p and q is given to us, right? If you go back to the function differential equation, right, p and q is given to us. We know p and q from the question, right? Okay, so here we know what is p. Can we figure out what is u? U prime is actually du dx. Remember, we're taking derivative with respect to x. Let's cross multiply. There is a 1 here, so let's cross multiply. This is in fact a separable differential equation for the unknown function u. So this is actually separable where u play the unknown function. U play the role of unknown function. So here your u is like your y. So this is just a separable differential equation, and we know how to solve, right? We can separate u on one side and x on the other side. So let's do that. So I'm going to divide both sides by u. U is the unknown function. U play the role of y here. And remember, p is a function of x. So here I can take the integral of both sides. So the left hand side, the integral is with respect to u. So the integral of 1 over u du is ln of u. And again, we're going to add c on the right hand side. And in the right hand side is the integral of p dx. So if I solve for u, that's going to be e to the power integral of p dx. A quick review. Let's say if I have a ln of x equal to y, right? That means x equal to e to the y. So that is what we use here. So this u play the role of x. And this side, this whole thing is like your y in this formula. So at the end of the day, my u is this. And then plus c, I'm going to avoid plus c here because, well, we're going to choose c to be 0. The So for the u, we're only looking at for a very specific one u. So well, just choose c to be 0 to make our life simple. So for this integral here, right, we are going to choose c to be 0. If you choose c to be some other number, it's okay, but your goal is to find the simplest possible u which will do the job, right? Just one particular u that will do the job. So why choosing an arbitrary c? Just choose c to be 0. So if we can evaluate this e to the power integral of p dx, that function is going to do this job for that particular function. So for that particular u, this equality is true. And this particular function u, this function u has a special name. We call this integrating factor. So this u is called integrating factor. So now we can go back, and now we know that for this u, the u that we just figured out, is my left hand side become uy prime, and of course my right hand side is uq. So for that, if I choose that particular u, our integrating factor, the left hand side become uy whole thing prime. So in that case, what is my equation become? Let's write it down. So for this u, the left hand side of my differential equation become uy the whole thing prime, and my right hand side, we have u times q. So again, I have to go back and just to make sure everybody got that. So remember, this is our original differential equation, right? We multiply both sides by u, but for that particular u, the left hand side is uy whole thing prime. So that is what I did, and the right hand side is uq. Okay, now if I take the, so now I have something prime equal to uq. So of course my uy, I'm taking the integral of uq, because to get rid of the first derivative, you take the integral of both sides, right? And I get that. We need to solve for y, so you divide both sides by u, because the goal is to find y, the unknown function, and that's it. We get my y equal to this, where u we know from this here. So we know what is u, right? And this gives the solution of y. And look at here, it's actually an explicit solution. U actually given, sorry, y is actually solved in terms of x. Amazing, right? It's not true. I mean, for other types of differential equation, it's a very unique situation. Very few differential equation you can actually write down an explicit formula and give it as an explicit solution. So let's summarize. What are the steps. So you have a first order linear differential equation written in the standard form. So this is the standard form of the first order linear. The step 1 is finding the integrating factor. So the integrating factor we usually denote it by this letter u or some other letter, but we're going to use u, and that is given by e to the power integral of p dx. Once you have the integrating factor, the step 2, the solution of this differential equation, this is going to be the general solution, and this is actually going to be explicit. So this is actually going to be general explicit solution. The y is going to be solved in terms of x, and the formula is y equal to, is going to be something over something. So what goes on the top is the integral of u times q. So you multiply the right hand side by u, and you take the integral of that and divide it by u. Here, when you find the integrating factor, just choose your constant of integration to be 0. Don't add any c, because you're looking for some particular integrating factor. Why making things complicated? Just, we need to find 1 and just choose c to be 0. But here, when you solve for y, of course, here you do not forget integrating factor. So you have to add c. So you always have to add that plus c there. So don't forget. In the next few episodes, we're going to look at a few examples of this. And always remember, you can do it.